Good afternoon, students. We will be discussing today the topic that is mentioned here, application of Woodward Rules for calculation of lambda max for the following systems. So this will be our topic today. So before we go to the specific compounds, we will first know what is Woodward's rule for the calculation of lambda max. Okay. So let us see. So I will be sharing this particular study material. This is a study material from NPTEL Pathshala. Okay, and this is the material that I will be sharing. You have all the contents here. So in short, it's a file of 21 pages. So definitely I will not go word by word. Just see this. Okay, what is Woodward-Fisher's rule and its application? Okay, what is the rule? The rule first came in 1945, and Woodward gave certain rules for correlating lambda max with molecular structure. So from the molecular structure, it will be always, you might be having a thought how we will know what is the lambda max of a particular substance or a compound which has certain functional groups, oxochromes, chromophores, and all that. Okay, so here we have the rule, and we can go to a calculation. It's a kind of numerical, and we can find out what is the lambda max. Okay, and then Fisher modified this rule. Okay, with more experimental data, and the modified rule is known as Woodward-Fisher rule. Now, what the rule tells us, it has a formula like this. Okay, lambda max is equal to base value. So there will be a base value for a particular compound. Type of the compound will have a base value, and there will be definitely on that skeleton structure there will be so many additives, means so many groups will be coming, like methyl, then other chloride, bromide, and all that. So based on that contribution substituents, there will be accordingly some addition of those values into the base value. So if you see one or two examples, you will definitely understand this. This is a raw or a kind of skeleton formula. Okay, then we will go to the exactly what is it. Now for this you will be needing to know some of the terms. Okay, now first we will go into what is the rule for conjugate diene or polyene. So that means what? We are concentrating on 1 alpha beta unsaturated aldehydes, ketones, carboxylic acids, and esters. These are the syllabus, these are the compounds we have to do. Conjugate dienes. Okay, so here at present we will be concentrating on this conjugate diene. Yes, this part we are doing right now. Okay, and all this are coming accordingly. Okay, so you will see just now what is the thing. So right now we are on conjugate diene or polyene. So the diene can be of different types. Okay, so this diene will have, according to the type of the diene, each type of diene or triene is having a certain fixed value of lambda max, which is known as the base value. This base value is what type of the diene or triene, and accordingly it will be informed to you in this rule what is the base value, and based on the this is the parent value, it will be always fixed, and according to the type of the number of substituents there, this will be added, and accordingly the final value will be coming out, and that will match with the exact compound. Okay, so what is acyclic dienes? Okay, acyclic dienes are those dienes which are not a cycle, it's not a cyclic compound, it's an acyclic compound. So there are two terms here, S trans, S cis. Now first of all we will go for the example. So let us read it out first. an acyclic diene exists mostly in S-transoid conformation, as shown in the case of the butadiene. So acyclic means it's not a cyclic compound. You can take butadiene. As acyclic dienes can rotate about their single bond. Now let me go to the next page and show you this. What is S-trans and S-C? This is the single bond. Based on this single bond, in reference to this single bond, these two double bonds are trans to each other. So S means single and trans means the double bonds bonded to this single bond, they are opposite to one another. And this is SC. This is a single bond. These two double bonds are on the same side. So this is SC. Okay. This is what is S-trans and SC. So you can understand very well. If these are there is a single bond, it can rotate always. So this double single bond can rotate and this can come in the same side. So it is always in an equilibrium. So here you can understand very well which will be in the maximum percentage. It will be the trans 97.5% and C is 2.5%. Now what is the absorption maxima or the base value? Now in this case the base value is 270 nanometer. But when you go to the same form, it is also SC. But since it is in a it's a cyclic compound. Okay, so the base value here is 256. Okay, so it is experimentally found value, and accordingly then the rule has been framed. Okay, so next let us go to the next type of diene. All these are type of diene, so it will come under the same category, conjugate diene. Now if it is cyclic dienes, you have two types of cyclic dienes. Okay, homoannular conjugate diene and heteroannular conjugate diene. You have two rings here. These are the dienes. Two double bonds are there. Okay, conjugated. So here both the double bonds are lying on the same cycle, same ring. So it is homoannular. Homo means same. Homoannular diene. And hetero means here also you can see that there are diene. This is a diene, but these two double bonds are lying in two different rings. So it is called heteroannular, and you can understand this one. It is cis, homoannular will definitely have to be cis, and heteroannular is definitely trans. But see, the base value has changed. Okay, so base value has changed. Here in case of trans, it was 217. Okay, so since the percentage was more, so we have the value only for this one. So 217. But when it is coming to a heteroannular diene, means in a cyclic compound, cyclic diene, the base value has changed. It is 234. Okay, and this one is you have a cyclic ring, but it is not having two rings. So therefore, this one and this one are having different base values, 256 and 273. So next let us go to the another terminology, that is endocyclic double bonds. What is endocyclic double bonds? Double bond is present inside the ring. Okay, when the double bond is present inside the ring, then what is the name? It is endocyclic double bond. Now exocyclic double bonds means double bonds present outside the ring, that is exocyclic double bond. Supposing this one is exocyclic. This one is exocyclic to this ring B. Okay, and this double bond in the ring B is exocyclic to A, and A is definitely not an exocyclic double bond because it is not connected with the ring. Okay, so here also you have the same thing. This double bond is exocyclic to this ring A, whereas this double bond is exocyclic to ring B. Okay. Similarly, these two are what? Exocyclic to this ring. Okay, both are exocyclic to A. Then this double bond is exocyclic to B. This double bond is exocyclic to C. This is exocyclic to A. This is exocyclic to B as well. Okay, so these are some of the terminologies you have to know when you will be given a compound to calculate the lambda max. Okay. Now come to the example, specific examples. Example 2. What is example 2? This is example 2. Okay. So how do you know this one? How do you correlate this one? The double bond present within the ring B is exocyclic to A. Where is so? We have already discussed all this. So I will not go word to word. Okay. Double bond which is common, okay, to two rings is considered endocyclic, okay, because at any given time the double bond will only belong to one ring. This double bond is endocyclic. It can be counted in this ring. It can be counted in this ring even. But this double bond is only for this ring. It cannot be a common ring. It is not in a common portion. So this double bond is endocyclic to this. This is also endocyclic to this. So how do you calculate all this? Okay. So based on the skeleton structure, you have to make a categorization, and accordingly you have to select the base value. Okay. So empirical rules of dying. How do you select the base value? The base value for homoannular, that means what? The same ring. Okay. So same ring, you know, it is always SC. So it is 253. Base value for heteroannular, it is transoid. You know, it is, if it is in two different rings, it has to be transoid. We have explained this one. So it is 214. So now, as and when you are having different types of substituents, you have to keep on adding the value. Okay, like this is the base value, and what are the different increments that will be done based on the structural information given to you. Supposing the ring is having some kind of substitution, that is alkyl substituents or ring residues attached to the parentyne 5 nanometer. Okay. So 5 nanometer, how do you calculate this one? Double bonds, if there are double bonds extending the conjugation, you have to add 30. Exocyclic double bonds 5. Polar substituents have got different values. If it is an asterisk, no, sorry, it is an anhydride, right? Okay. So if it is an anhydridic group, so it is what? It is no substitution, no addition, no increment. It is a methoxy or alkoxy group. It is +6. Thiol group. It is alkylated thiols. Yeah. So it is 30. Then Cl, Br 5, Nr2 secondary amines. It's 60. With the help of this rule, UV visible absorption maxima can be predicted. Now let us see some important points are discussed here. While calculating lambda max, only those alkyl substituents or ring residues are counted which are directly attached to the carbon atom, making conjugated system within the compound. So this is an important point. So we will count only those alkyl additions, increments. Okay, additions will be considered only those will be considered which are directly attached to the carbon atom, making conjugated system. If it is out of that conjugated system, we cannot add it. Okay. If a molecule has both homoannular dienes and heteroannular, both are there, then which base value you will select? Then always use homoannular diene as the core chromophore. It will be the means here you have already got this value, then in that case you will be counting 253, not 214. Okay. So we will take some of the examples. We will be comfortable soon. So here let us take this. So what is this? It is what type of diene? Can you tell? This is lying in the same ring, in single ring, and it is a diene, but this double bond is out of the ring. So therefore it will be counted as heteroannular. So therefore the base value is 214. Now what are the increments? Now this is a conjugate system. Okay, to this conjugate system, what you have? This is what? This is alkyl.